Do you have any doubts? Any doubt or anything that you want to ask? Any question?
No.
No, not right now. Okay. Hello, Abdurrahman. How are you? Am I audible?
Yes, sir.
Okay. So you are completing the notes, right? Yes, Abdurrahman. No. Yes, Abdurrahman, you have completed the notes, na?
No, sir. I'm just writing the questions.
अच्छा फिर बाद में जो PDF दे रहे हैं हम किस लिए दे रहे हैं आपको? हाँ. You have to complete the notes also, na? Because see, like you won't always get only numericals. You will be getting some theoretical question can also come, na? है ना? So please like complete the notes, or maybe if you don't complete the notes, then at least get it print out. वगैरह कुछ ले लीजिए उसका, है ना? You should have something to read. You have taken the printout.
Yes, sir.
Okay, fine. Okay, so let us just wait for 2 more minutes, then we can start. And I hope you guys got the information about Viva. Yes, Abdurrahman and Minashi. Minashi, आपको मिला था?
Yes, sir.
I could not hear that. What did you say?
Yes, sir.
You got it. Okay. Abdurrahman, did you get the information about Viva?
Sir, was it informed last week?
हाँ, वही है. You must have got it last week only.
Yes, sir.
So let us start this class. In last class, we learned about pK and K, that is the dissociation constant of acid. Dissociation constant of acid. So that is equal to the concentration of H plus whatever we have been liberated, whatever has been liberated from the acid, and into the anions concentration divided by the concentration of the acid, divided by the concentration of acid. Okay, at equilibrium. These all things are at equilibrium. Okay, now let us see what happens. Now, let us see what happens when we have a weak acid. Okay. So before discussing about weak acid, let us write a reaction like this. A is in equilibrium with B and C. A is in equilibrium with B and C. Okay. Now, when we have this type of condition, then we write three things. The initial, then what do we write? Initial, and then Abdurrahman, tell me, initial concentration, and then what do we write?
Equilibrium.
Change. And then we write equilibrium, na?
Yes, sir.
Change and equilibrium. So let us suppose initially it was 10 and the B was 0, C was also 0. Changes of, we will say that here we have the stoichiometric coefficient as 1. So we'll write minus x and plus x, and plus x of B and C will be formed. And the equilibrium concentration will be 10 minus x This will be X and this will be X. Now, interesting point when we have only one reactant. Interesting point when we have only one reactant is that the change, whatever I am talking about now, the change, whatever I am talking about. So let us suppose that initially it was 100. Initially it was 100. Now, whatever the change may be, the change will be either half of it or 1/3 of it, 1/6 of it, maybe 1/97th of it. Whatever is the case, I can write the change. I can write the change as a fraction. I can write the change as a fraction, and I can say that if I take 1 mole of A, then I am going to dissociate. That means I am going to form, how many moles of A are going to react? Half moles of A is going to react, or 2/3 moles of A is going to react when we have only one reactant. Why? If we have two reactants, please listen very carefully, Anna. If we have two reactants, then here the reaction of A, the reactivity of A, and the tendency to form product is not only dependent on A, it is also dependent on the availability of B and the tendency of forming product of B. Because here A and B are dependent on each other, we write the change. But when we have only one reactant, that is A, when we have only one reactant, that is A, only one reactant, that is A, then we can write the change as the fraction of reactant reacted. First, tell me, do you understand this point? Yes or no? That if we have only one molecule, if we have only one reactant molecule, then only we can write as a fraction of reactant that has reacted. Is this clear? Yes or no, guys? Mazia, Mehreen, Yusra, Abdurrahman, Razan.
Yes, sir.
Yes, all of you. Yes or no?
Yes, sir.
Yeah, okay. Yusra बोल रही है बस. Yes. What about Razan, Abdurrahman, and Mazia, Minashi?
Yeah.
Got it? No. So when we have only one reactant, then only we can write as a fraction. Otherwise, it will be, if I have 2 moles, if I have 2 different reactants, then A will be also dependent on the other reactant. When we have only A, then we can write as a fraction of reactant. Now, this is very similar to the case that we have when we have a acid or a base. When we have acid or a base. So see, we have Ha is our acid, and it is in equilibrium with H plus A negative. H plus and A negative. Let us suppose at initially we had C concentration. C is the concentration of acid. What is the concentration of acid initially? What is the concentration of acid initially? What is the concentration of acid initially?
C.
Somebody please repeat. C. Wait a second. I need to get my earphone. I can't hear you, please. Yeah. Okay. So I hope I am audible. Yes. So C is the initial concentration of the acid. So what will be the initial concentration of H plus, guys? Initially, how much H plus will be there and how much A minus? When we have not even added in the water. So in water, how many H plus and A minus will be there? If I have not added the acid. 0, 0, no? Yes or no? From the acid, there will be no dissociation. Yes or no?
Yes, sir.
Okay. Now please listen very carefully. The change. I am saying we have an acid. Let's suppose we have an acid Ha, and no matter how much moles we are taking, no matter whatever the concentration is that, whatever concentration we are taking, half of the concentration reacts. Half of the concentration reacts and dissociates. Okay, how much? How much is reacting? How much is reacting, guys? How much is reacting? Half. Okay. So if I take 10, initially, what will be the change? What will be the change?
5.
5. 5 will be reacting, minus 5. Hai na? If I take 20, then it will be how much?
-10.
Minus 10. If I take 100, then it will be how much?
-50.
Minus 50. Now you can see, I can write this change. I can write this change in terms of the initial and the fraction. I can write this as minus of 10 into 1 by 2. Yes or no? Correct?
Yes, sir.
I can here write minus of 20 into 1 by 2. Yes or no?
Yes, sir.
And here I can write minus of 100 into 1 by 2. So essentially what I'm writing, whatever be the concentration into the fraction that is getting dissociated, and that fraction that is getting dissociated, it is represented by alpha. Alpha is what? Alpha is the fraction that is getting dissociated. Is this clear? Yes or no? Please tell me. है ना? So I will write minus of C alpha. What will be the change? Minus of C alpha. Alpha is the fraction. Alpha is the fraction that is getting. Now it will not be always half. I hope you are like mature enough to understand that it will not always be half. It may be any fraction. It may be any fraction that we are representing by alpha. Okay. Now, अब आप लोग तो बता सकते हैं, है ना? If this is my change, H plus will be plus C alpha, and A minus will be minus C alpha. Sorry, plus C alpha. A H plus and A minus. Yes or no? Both of them will be plus C alpha, right? Because it is getting produced. Array, yes or no?
Yes, sir.
Thank you very much. Now at equilibrium will be C minus C alpha. This will be C alpha, and this will be C alpha. Alpha, like don't just get very afraid of this alpha, है ना? अब alpha आपका दोस्त हो गया, ठीक है? You are in 11th standard. Alpha is your friend only. Don't get confused and don't get intimidated. It is just a fraction. Fraction आप लोगों ने 7th class में पढ़ाया कि नहीं पढ़ाया? You have learned fraction in 7th, 6th standard ना? Yes or no? हाँ, तो alpha वही है. Alpha is fraction only. It is nothing. It is just a fraction. Okay, it is just a fraction. Okay. So now we can also write the Ka. Dissociation constant of the acid. This will be equal to the concentration of H plus into the concentration of A negative divided by the concentration of HA at equilibrium. All of these concentration that we write for the dissociation constant will be at equilibrium. So H plus and A negative is C alpha into C alpha divided by C minus C alpha. So now what I can do from the Ka, I can, first of all, I will write C square alpha square, and here I can write C upon C into 1 minus C alpha, and then I can cancel this C and C. So for which I will get the K is equal to the Ka, dissociation constant of acid, is equal to C alpha square upon 1 minus C alpha. Is this clear? Yes or no? Please tell me. अच्छा एक second, यहाँ पे this will be 1 minus alpha because C हमने common ले लिया था. This will be 1 minus alpha. Sorry. Here it will be getting 1 minus alpha. है ना? C we have taken common, so C into 1 minus alpha, where K is will be equal to C alpha square upon 1 minus alpha. What is alpha? Alpha is a fraction. Fraction of what? Fraction of the molecules getting dissociated. It is also known as the degree of dissociation. है ना? Degree of dissociation. अच्छा एक बात बताइए. 0.25. Is this a fraction? Yes or no? 0.25. Is this a fraction? Yes or no?
Yes, sir.
yes, है ना, 0.25 is a fraction. ठीक है, ऐसे नहीं कि ये fraction नहीं, it is a fraction. Okay, so when you will always have alpha which will be less than 1 only. It will be less than 1 only. Okay, because fraction, when we say how much it is getting dissociated, so complete में से कुछ dissociate होगा, that means it will be always total minus something, so it will be always less than 1. It will be always less than 1. Is this clear? Yes or no? Please tell me. This whole equation, K is equal to C alpha square upon 1 minus alpha. Is this clear?
Yes, sir.
This is known as the relationship between dissociation constant and degree of dissociation. Degree of dissociation. Now, when you have weak acid, let me write. In weak acids, weak acid में what you will be getting? More H plus or less H plus? Weak acid में what will you be getting in weak acid? More number of H plus ions or less number of H plus ions? Weak acid will liberate H plus easily or not so easily?
And not so.
Not so easily. So the number of H plus will be less. That means less number of molecules gets dissociated. In weak acid, very less number of molecules get dissociated. Hence, the alpha is what? It is very, very small than 1. It is very, very smaller than 1. You can also see when you will have a weak acid. Now, when you will have a weak acid, then Ka, you know that weak acid में क्या होगा? Ha equilibrium with H plus A negative. So mostly what you will be getting, the product will be less, the reactant will be more, and if the product is less and reactant is more, that means you will have a Ka which will be somewhere around 10 to the power minus 3. 10 to the power minus 3. Yeah? So that means alpha is what? Alpha is going to be very, very less. Alpha is going to be very, very less. That is very, very less than 1. And that is why 1 minus alpha, it is approximately equal to 1 for weak acid. This is very important. For which type of acid? For weak acid, it is approximately equal to 1 only. It is approximately equal to 1 only. And that is why for weak acids, the Ka, which is equal to C alpha square upon 1 minus alpha. So 1 minus alpha, it is already equal to 1 only. Right? It is equal to 1. Why? Because alpha is what? It is equal to C into C alpha square upon 1. Since alpha is very, very smaller than 1. Hence we can write Ka, it is equal to C alpha square. Now, when you have this equation, relationship between Ka and C alpha square for weak acid, this is the relationship. Okay, this is the relation between Ka and alpha of weak acid. So if we have Ka is equal to C alpha square, then I can write alpha. This will be equal to how much? This will be equal to Ka upon C, that is the concentration, that will be alpha square. And if I put root, it will be equal to alpha. It will be equal to alpha. And this is how you can calculate the degree of dissociation of a particular weak acid. Is this clear? 3 points, yes or no? Is this relation clear? Are these two relationship clear, yes or no?
Yes, sir.
Yes, sir.
Now let us write about the degree of dissociation. We have introduced degree of dissociation, but we have not written anything about degree of dissociation. Okay. So what I will do, I will write degree of dissociation like this. That is the fraction, है ना? Fraction, that is alpha only. Nothing but it is alpha. ठीक है? अब ये तो आप लोग को पता है. What you understand now? What is degree of dissociation? Yes or no? Please tell me. All of you understand this? Yes or no? No, nobody understand degree of dissociation. We just learned it, na?
Yes, sir.
You understand what it is, right? You understand what it is. Ab
Yes,
what
sir.
you have to, okay. So what we have to write here, I will be just, you will get what, this will not be blank when you are writing the notes. Okay, when I will give you notes, here you will be having some text, which will be defining degree of dissociation and the other things. Okay, and the other things. So please write the notes. If you are writing the notes, then only it will be fruitful. Otherwise, just problems करने से उतना नहीं होगा. Okay. So when you will write the notes, this portion will not be blank. Now moving on. Let us also write now addition of base in water. We have added acid in water and quantified the relationships. Now add addition of base in water. So obviously I'm not going to explain so much, because we have done similar things with acids also. So base, it is going to give me B positive plus OH negative in water, OH negative. So the Kb will be equal to how much? It will be equal to the concentration of B positive into the concentration of OH negative divided by the concentration of BOH. That is the base. BOH, that is the base. This is Kb. And what is Kb? Kb is the dissociation constant. Dissociation constant of base. Dissociation constant of a base. And what will be pKb? So P of anything, it is equal to minus log of that thing. So minus log of Kb will be pKb. Minus log of Kb will be pKb. So for Kb strong acid, strong base has high value of Kb. Strong base has high value of Kb. So now you tell me, strong base has dash value of pKb. Look at this relationship. What is the relationship between pKb and the Kb? It is a minus of something, ना? देख के बताइए. Strong base has dash value of pKb. High होगा या low होगा? You have only two options. No problem if you get it wrong, but please try. Look at the relationship, है ना? Try to see. This is mathematics, not chemistry now. You have pKb. This is equal to minus log of Kb. Okay, think about it for 2 minutes. Send the answer in chat. It will have high value of pKb or small value of pKb, large or small value of pKb. Okay, Khalil. What about others? Please tell me, huh? Mazia, Minashi, Abdurrahman, Mehreen. Okay, Abdurrahman sent an answer. Razan. Here, Razan. Okay, Minashi. Waiting for Mazia and Mehreen. Yes, Mazia. Mazia and Marine, are you guys there? Mazia, turn the mic on. What happened? It seems Mazia is not here. What about Mehreen? Mehreen, are you there? Raise your hand, say something, send in chat something, है ना, तभी तो पता लगेगा that you are here. Okay, it seems they don't have good connection. Yes, so all of you guys are right. All of you guys are right. Strong base has dash value of pKb, है ना? Dash value of pKb. So, Mehreen, can you turn the mic on?
Yes, sir.
हाँ, अब यहाँ पे ऐसे बताइए आप.
Sir, I sent
Strong-
it to the other
हाँ.
Learnivio.
Person. Okay, no problem. आप ये बताइए यहाँ पे. For a strong base, what should be the value of Kb? High or low? Kb का value क्या होना चाहिए? High or low? Tell me. Okay. Where is Mehreen? Mehreen, can you please keep the mic on? Mehreen, you tell me A or B, which is a strong acid? Sorry, which is a strong base? Really sorry, which is a strong base? A or B?
A.
A is strong base. Can you calculate the pKb for A and B? Mehreen,
Yes, sir.
calculate the pKb for both the things now. This is the formula, minus log of Kb. Khalil, आप लोग का physics, you read physics here? You study physics here, Khalil?
No, sir.
Achha. So any other subject?
No, sir. Only chemistry.
Okay, only. Minashi, you have physics class in Learnivio only.
No, sir. School, sir.
School, क्या बताएंगे आपको स्कूल में?
Hmm?
Yes, Minashi.
Yes, sir.
What will they teach in school?
My practicals are starting on Sunday, sir.
So
She told to join at 5 o'clock for revision.
important questions बताएंगी. अगर important questions बताएंगी जो एग्जाम में आ जाए तो चले जाइए आप, है ना. बट अगर वो पढ़ाने वाली है एंड इफ यू थिंक, आप देख लीजिए क्या बेहतर है आपके लिए. व्हाट इज गुड फॉर यू. नो लाइक हम ऐसे सार्काज्म नहीं कर रहे हैं. if she is going to tell you some important questions, है ना, ऐसा होता है. like in many schools the teacher they tell you some important portions, important topics, तब तो please, है ना, you can go. And if she is just going to teach, then I may ask you that please be here only. I think that will be better for you. What do you think, Minashi?
It's practicals.
अच्छा, वो प्रैक्टिकल करा रही हैं आप लोगों का, तो ये बताइए ना, आप लोग क्लास लेंगे. हमको लगा एक्स्ट्रा क्लास आपने लिख दिया है. ओके फाइन, इफ इट इज प्रैक्टिकल देन यू कैन लीव, नो प्रॉब्लम.
Yes, sir.
Razan, you study physics here? Physics or any other subject?
Physics.
Physics में हो गया syllabus? What you are doing then? Now?
Exams and the test.
Test and revisions.
Yes.
So how does that go? Like 1 hour revision, then 1 hour test, something like that?
Yesterday, so we only did the test part, and in the next class we'll be discussing the question paper.
Acha, the question paper. So it is like full test or chapter wise?
Chapter wise.
Chapter wise. So students आ रहे हैं?
Yes, sir.
अच्छा, ठीक है then. यस महरीन, पीकेबी। फिर लर्निवियो को भेज दिया क्या आपने?
Yes, sir.
यस, पीकेबी। टेल मी द पीकेबी। आई आस्क्ड यू टू कैलकुलेट द पीकेबी ना?
Yes, sir.
हाँ, डिड यू गेट द पीकेबी?
No.
व्हाई? अरे व्हाट हैपेंड? Keep your mic on. What is pKb equal to? Tell me what is the formula for pKb?
Minus log KB.
Minus log of Kb. Were you present in the last class?
Sir, I joined from the half.
हाँ, तो log आपने नहीं पढ़ा था यानी मेरे से. Did you study log?
No.
Very good. Did you watch the lecture?
Yeah, I watched this starting only.
Starting. So उसमें log पढ़ा आपने? Did you learn log there while watching the video recording? No. In last class only we did log, na? हाँ, last class only we did log. ये सब Marine, these things. नहीं किया है, मतलब अगर किया रहता तो दिख जाता ना आपको. नहीं किया आपने Marine?
No, sir.
अच्छा, तो you know something about log? No. नहीं पता है यानी कि, तो फिर आपने कैसे बोल दिया पीकेबी कैलकुलेट कर लेंगे आप? प्लीज वॉच दैट लेक्चर, ओके महरीन? सो दिस विल बी माइनस लॉग
Yes,
ऑफ,
sir.
minus log of, now listen very carefully. Minus log of what is kb? Fast, tell me fast, what is kb? What is kb? Marine, I'm asking you what is kb? तो वैल्यू दिया हुआ है ना यहाँ पे, देख के बताइए आप.
10 raised to 4.
10 raised to 4. So what happens in log? Whatever exponent is there, it comes down as multiplication. So this will be minus 4 of log 10. So and log 10 it is equal to 1. So it will be equal to minus 4. Okay.
Okay, sir.
What is this? Is the pkb. What is this?
PKB.
pkb. Now tell me pkb
Is
for this will be equal
log
to minus log of
KB. Minus log of 1.
1. Okay. So see, देखिए 10 to the power, sorry 10 ऐसे होता है. So here we have 10 written, which is not written like that. Okay, it is implicit that there will be a 10 there. So it is like this: 10 to the power 2, it is equal to 100. This is the concept of log. So you tell me log 10 1, it is equal to how much? 10 to the power how much will be equal to 1? 10 to the power how much will be equal to 1? अरे 10 to the
One.
power x 1. 10 to the power 1 तो 10 होगा ना?
Yes, sir.
So I'm asking 10 to the power how much will be equal to 1?
10.
10. 10 to the power 10 is equal to 1. 10 to the power 10 will be equal to 1. Marine, you are not thinking properly. घबराइए मत, बताइए 10 to the power how much will be equal to 1? नहीं तो आपकी कोई छोटे भाई बहन है 8 क्लास में, उनसे पूछ लेंगे हम, फिर आपको शर्म आएगी. भूल गए एक्सपोनेंट्स एंड पावर्स, भूल गए बच्चे यहाँ पे 8 क्लास का. डू यू हैव एनी यंगर सिबलिंग महरीन?
Yes, sir.
कितनी क्लास में है?
6.
6 में तो नहीं होगा, 6 में तो एक्सपोनेंट्स नहीं है. बच गए आप, नहीं याद आ रहा? You can't remember this. 10 to the power how much will be equal to 1? Huh?
10 to the power 1.
10 to the power? Come again?
1.
1. 10 to the power 1 आप बताइए कितना होगा?
10.
तो फिर 1 कहाँ आ रहा है?
10 to the power minus 1.
10 to the power minus 1. ये तो 1/10 हो जाएगा. It will be equal to 0.1. एक्सपोनेंट्स भूल गए. अरे महरीन 10 to the power 0 is equal to 1 ना. याद आया?
Yes, sir.
Anything to the power 0 is
The number itself.
anything to the power 0 is 1, not the number itself. Anything to the power 0, a to the power 0 is equal to 1, not the number itself. Okay, so log of 1 it will be equal to 0. ठीक है, log of 1 will be equal to 0. अब बताइए यहाँ पे which is smaller, 0 या -4?
-4.
So strong base has lower value or higher value?
Higher value.
Higher value of
Ah,
pKb. pKb is
Strong value.
strong base. क्या महरीन? Strong base. Tell. Strong base
Strong base.
has -4 and weak base has
0.
0. What is that 0? Values of pKb na, which is lower, 0 or -4, which is smaller?
-4.
-4. So strong base should have small value या large value?
Small value.
Small. Weak value नहीं बोलिएगा. Weak value. Small value. What value?
Small value.
Small value of what? Kb या pKb?
pKb.
pKb. And kb के लिए?
High value.
Okay, strong base will have dash value of kb. इसमें
High
यहाँ पे
value.
लिखिएगा. हाँ. Strong base has dash value of kb. Then also you all will write strong acid has dash value of pKa. Strong acid has dash value of Ka. ठीक है? You all will write these things. Abdur Rahman, you can see. Can you see this? Fill in the blanks. Yes, Abdur Rahman. कहाँ चले जाते हैं बच्चे? 5 मिनट बाद फिर हाँ पड़ेगी. अभी बोल रहे हैं. मेरी आवाज देर से पहुंच रही है आपको अब्दुल रहमान? No, फिर why so late? हाँ. Can you see this fill in the blanks?
Yes,
you're not writing notes, but ये complete करना है. ठीक है? All of those who will get the notes, ना, you have to complete this. Okay. Then now let us look at the situation, and as we have written this now for Ka, we can write the same thing for Kb also. We can write the same thing for Kb also. Here also what is going to happen, we'll have base OH in equilibrium with B plus OH negative. I will write initial change equilibrium, है ना? Ice table. What table? Ice table. Base is concentration C, and initially these are zeros. Change will be C into the fraction. What is alpha? C into the fraction minus, because it is in reactant, it is getting consumed. B positive and OH negative, these are being produced, so this will be plus C alpha plus C alpha. Equilibrium will be C minus C alpha. This will be C alpha. This also will be C alpha. What is alpha? Alpha is just a fraction, nothing else. So I can write now Kb, it will be equal to the concentration of B positive into the concentration of OH negative divided by the concentration of B OH, that is the base. So this will be equal to C alpha into C alpha divided by C minus C alpha. Now this will be equal to C square alpha square C into 1 minus alpha. C and C will get cancelled, and you will have the relationship of Kb similar to that of Ka, which will be equal to the concentration into the degree of dissociation squared upon 1 minus alpha. 1 minus alpha. This is the relation between Kb and alpha, degree of dissociation. Kb and alpha, that is the degree of alpha is what degree of dissociation, a fraction. Now, again for weak base, I can write for weak base, alpha is what very small than 1, and therefore 1 minus alpha will also be equal to 1 approximately. It will be no change. So hence we can write the Kb will be equal to C alpha square upon 1 minus alpha, and the Kb will be equal to C alpha square upon 1, as 1 minus alpha is equal to 1. Next we have Kb will be equal to C alpha square. What is this relationship? Relation between Kb and Kb and alpha square, Kb and alpha, that is degree of dissociation for weak base. These things are very important for weak acid and for weak base. Okay, weak base. Next we have alpha will be equal to under root of Kb upon C, under root of Kb upon C. Is this clear? Yes or no? Please tell me.
Yes,
Are
sir.
these things clear? Okay. Right. So we have the degree of dissociation, acid, base, everything. So we can classify things into, we can classify all the electrolytes. You can see that electrolytes. They can be either acid or they can be either base. In acid also we will have two different classifications, strong and weak. In base also you'll be having two different classification. Weak and strong. So the relationships, how are the relationships? So for strong acid, you'll have Ka, it is equal to C alpha square upon 1 minus alpha. For weak, it is equal to how much? For weak, it is equal to Ka is equal to C alpha square. Here also for base, the Kb it is equal to C alpha square. And for strong, the Kb is equal to C alpha square upon 1 minus alpha, 1 minus alpha. Now, here for weak, you also have a relationship between alpha, and alpha will be equal to under root of Ka upon C. And for weak base also, alpha will be equal to under root of Kb upon C. These things are very important. Whenever you are writing the relationship, you should keep in mind the strong and the weak behavior, strong acid or weak acid, or strong base or weak base. Is this clear? Yes or no? Please tell me. Is this clear, guys? Yes or no?
Yes, sir.
Okay. Now let us see a question, and then we can understand how are we going to classify between strong acids and strong bases and weak, strong and weak things. Okay, strong and weak. So the question is, calculate the degree of dissociation. What is degree of dissociation? Alpha. Degree of dissociation of HF, whose Ka is equal to 3.2 into 10 to the power minus 4. Okay, you have to calculate the degree of dissociation of HF, whose and concentration of solution. Concentration of solution is 0.02 molar. 0.02 molar. First of all, my first step would be identification whether it is a strong acid. It is an acid. HF is an acid, that is for sure. Now, is it a strong acid or weak? Tell me, है ना? This is the first thing that I have to. Then only we can move to a particular relationship. Yes or no? Then only we can identify the relationship. Yes or no, guys? We have to identify whether it is strong or weak. Yes or no? अरे भाई, yes or no कोई है कि नहीं? Are you guys there? Hello, students.
Yes, sir.
Yes, sir.
Okay, thank you very much. Thank you very much. Now we have either it will be strong or it will be weak. Okay. So HF is a acid or base. HF is a acid or base. HF is acid or base. Tell me.
Acid.
Acid.
Very good. Now, if it is strong, then it will have high Ka, right? If it is weak, then it will be having low Ka. Correct? Yes or no?
Yes, sir.
अब ये देख के बताइए, is this high or low?
Low.
Low, na? 10 to the power minus 4. So low. And see, like you should have an intuition what this value is saying. Please listen very carefully. It is saying that let us ignore this 3.2. Okay, I'm just saying that ignore that 3.2. We are just looking at this exponent that is 10 to the power minus 4. Okay, we are just looking at the exponent that is 10 to the power minus 4. Now, what it is saying that value, बोलना क्या चाह रहा है? वो ये बोलना चाह रहा है कि like when you have HF and it is in equilibrium with H plus F negative, then the Ka, it is equal to the concentration of H plus into the concentration of F negative divided by the concentration of HF. And here you can see these are what? These are product. So product upon reactant, it is equal to 10 to the power minus 4, which means product upon reactant, it is equal to 1 upon 10 to the power 4. That means if I have 10,000 moles, if I have 10,000 moles of HF, then I will be getting 1 mole of product. Yes or no? This is what it is trying to say. Right, guys?
Yes, sir.
Then obviously it is what? It is evident from the value that it is a weak acid. It is a weak acid. Is this clear with everyone? Whenever you get a value, try to understand what the value is trying to speak. Okay. It will always give you some information about whether the reaction is going for, whether we have more products or whether we have more reactants. What is more dominant? And then you are going to understand whether it will be strong acid or a strong base or a weak acid or a weak base. Okay. So now we have understood HF is a weak acid. Weak acid as Ka is equal to 3.2 into 10 to the power minus 4. Now we just have a relationship. Simple relationship क्या है यहाँ पे? We have a relationship where we have alpha, it is equal to Ka upon the concentration C divided by, under root. So Ka 3.2 into 10 to the power minus 4 divided by C, that is equal to 0.02 under root. Just please calculate this. Let me know if you're done. And just give me 2-3 minutes, okay? Actually, my grandmother has just come. हम बस सलाम करके आते हैं, ठीक है? You calculate this, send the answer in chat. Yes, so I'm back. Okay, please raise your hand if you are not comfortable with calculating these type of things. Okay, Abdurrahman, okay. इतना नहीं होगा. I mean, you are near, but I don't think it is right. How did you calculate, Razan? Razan, you are near, but it is not accurate. There is some error. Okay. Abdurrahman, first thing first, we will simplify all these values. जो भी decimals वगैरह में है ना, we will clear up those decimals, है ना? We will not keep things as decimals. We will clear up those decimals first of all. Okay. So whenever you have to calculate these things, never calculate in the same, like here you don't calculate, okay? Whenever you have to do simplification, you just make a line in your notebook like this and do the simplifications here. Okay, but again, it should be very clear. So we have 3.2. I'm not interested in the root. I am just figuring out how to write this fraction without the decimal points. So what I will do, I will write 3.2 को हम क्या लिख सकते हैं 32 into 10 to the power minus 1 into 10 to the power minus 4 divided by 0.2. I can write as 2 into 10 to the power minus 2. Is this clear, yes or no, Abdurrahman, till here?
Yes, sir.
Then what I will do, I will just, this will be 16, right?
Yes,
So now
sir.
we have 16 into 10 to the power how much?
Minus
Tell me.
5.
10 to the power minus 5, है ना? Now this is simple. If you have some idea of log, this is going to be simple. You can write under root of 16 into 10 to the power minus 5. So 16 root, it will be how much? 4, right?
Yes, sir.
4 into 10 to the power minus 5 by 2. Is this correct? Yes or no? Are you comfortable with this?
Yes, sir.
है ना? Root मतलब होता है 1 by 2.
Yes, sir.
So now we have 4 into 10 to the power minus 2.5. Correct?
Yes, sir.
अब याद देखिए, कुछ log वाला याद आया आपको? Last class में थे आप, Abdurrahman?
Yes, sir, I was.
You were present now. So we have calculated this type of 10 to the power negative somethings. See, 10 to the power minus 6.4 we have calculated. So we can calculate this also. How will we calculate? First of all, we'll write this as 4 into 10 to the power. Now I will write 2.5. Sorry, I will write minus 2.5 as the difference of few things, right? As a difference of few things. ये एक सेकंड रुक जाइए आप. ये आपने ये -5 गलत बता दिया. हमको लगता है -3 होगा यहाँ पे. नीचे 10 to the power -2 भी है ना. It will be -3. So this will be minus 1 by 1.5. दिख गया आपको अब्दुल
Yes, sir.
Okay. So minus 1.5. So I can write minus 1.5 as 0.5 minus 2. Correct? Yes or no?
Yes, sir.
Then this will be equal to 10 into 10 to the power 0.5 into 10 to the power minus 2. अब ये बताइए log of how much? This is the blank here. 10. Log of how much is equal to 0.5 or near to 0.5? Log of how much? You remember the values of log? You have written the log values. Khalil, sorry, Abdul Rahman.
Yes, sir.
हाँ तो देखिए log values में देखिए 1 से 10 तक. Log of what is near to 0.5?
Log of 2,
Log of 2 is how much?
0.3.
And log of 3 is how much?
So yes, so 0.48.
है ना? So it is near to what? Log 3. So we'll just write 10 to the power 0.5. It will be equal to 3 into 10 to the power minus 2. So this will be equal to 12 into 10 to the power minus 2. Okay, not so tough, right, Abdul Rahman?
Yes, sir.
Okay, so देख के डर मत जाइएगा. You just try to do this thing. Try to simplify it in like the numbers that you are comfortable with. है ना? We are always comfortable with tens and any whole number. So जो भी decimal में है, try to eliminate those decimals and write in the whole numbers. Okay. Razan, how did you calculate 0.16? Can you tell me? Yes, Razan.
Yes, sir. I just divided it 0.02 and 3.26, and then the answer was 160. So I forgot to do the root part.
Ah, okay, okay. You forgot to do the root part. Okay, fine. So log is very helpful. Okay, log is going to be very helpful for you guys. So just write this down. Raise your hand if you're done. Okay, only Razan is done. Abdul Rahman, Khalil, Mazia, Mehri, write fast. Okay, everyone is done. Mazia, you are not done. Mazia and Abdul Rahman not done. Abdul Rahman is done. Mazia, okay, Mazia is also done. Okay, fine. Let us write another question. Write this question, guys. All of you done writing the question, yes or no? Raise your hand if you're done writing the question. Okay, Razan, tell me, whatever molecules we have been given, HF, HCO, H, and HCN, these are acids or base?
Acid.
Acids. And that means whatever values we have been given, so we have been given Ka, correct? Yes or no? We have been given Ka, na?
Yes, sir.
Okay. And what are they asking? Calculate the ionization constant of the corresponding conjugate base. So we have to calculate Kb. Yes or no?
Yes.
Okay. So that means essentially what they are asking, what is the relationship between Ka and Kb? So we have to look at the relationship between Ka and Kb. Okay. Relation between Ka and Kb. Now, see, it is very important. Whatever you have acid bases or anything in your ionic equilibrium, the most important relationship is the ionic product of water. Okay, the ionic product of water. So if I look at the ionic product of water, that is going to tell me about the Ka and Kb's relationship. K's and Kb's relationship. So wait, let me have Ka here. So let me first of all write a reaction. Ha in equilibrium with H plus plus A negative. This is going to be the relationship, yes or no? Yes or no? And if I write it, let me write it all the material here. So Ha plus H2O, it is in equilibrium with H3O plus A negative. So for this, we have two things. This is my acid, and this is my conjugate base. So for acid, I will write the Ka. This will be equal to the Ka will be equal to H3O plus concentration into A negative concentration divided by the concentration of what? Ha. Why? Because water is going to be a pure liquid. That is why we are not taking its concentration. Next is, let us write now the reverse reaction. Conjugate base, that is A negative plus H3O plus. It is going to give me Ha plus H2O. So for this, we can write the Kb because we have the base in reactant. So this will be equal to, now we will only write Ha, the concentration of Ha. Why? Because only Ha is an aqueous condition. Water is a liquid, pure liquid. That is why we are not taking its concentration, divided by the concentration of A negative into the concentration of H3O positive. Now, if I look at this reaction, if I look at this relationship, Ka into Kb, then I can say Ka, it is equal to the concentration of H3O plus into the concentration of A negative divided by the concentration of what? Oh, sorry. I made a mistake here. Wait a second. I should writing here base that is reacting with water, not H3O plus, and it is going to give me Ha plus OH negative. So there will be some changes here. Ha will be there and OH negative will be there. And here we'll be having only A negative. Sorry for that mess up. Here we'll be having HA concentration into the concentration of OH negative divided by the concentration of A negative. We have acid and we have base, both are acting on water, and we are calculating the Ka and Kb. So Ka is this much divided by Ha into Kb will be the concentration of Ha into the concentration of OH negative divided by the concentration of A negative. Here we can do some cancellation. A negative and A negative will cancel, Ha and Ha will cancel, and we will get, this will be as the concentration of H3O positive into the concentration of OH negative. So this is what ionic product of water, which will be equal to 10 to the power minus 14. Hence, Ka into Kb, it is equal to 10 to the power minus 14, and we can also write Ka into Kb, it is equal to Kw. It is equal to Kw. But please remember, this Ka and this Kb will be only for the corresponding acid base. So we have acid Ha, and whose conjugate base we have. So these will be the conjugate acid base pairs relationship. So here we have HF first of all. HF is 6.8 into 10 to the minus 4. HF 6.8 into 10 to the power minus 4, right? This is my Ka. This is the value of Ka for HF. That is why now we can write for Kb, for F negative, we have relationship Ka into Kb, it is equal to Kw. Hence Kb will be equal to Kw, that is 10 to the power minus 14, divided by Ka, which is 6.8 into 10 to the power minus 4. Enough. So you calculate this and also calculate Ka is equal to, for the next one, that is HCOH, 1.8 into 10 to the power minus 4, 1.8 into 10 to the power minus 4 for HCOOH. So calculate Kb for HCOO negative. So here also you will be writing the same thing. Okay, so you will substitute the value of Ka and you will substitute the value of Ka and Kw and also calculate the Kb here. Kb will be equal to Kw upon Ka. So please calculate these two and tell me the answers. Yeah, I've got answer from, okay. It seems correct. Let us see what others have to. Yeah, I think it is correct only. Waiting for others. Okay, yes, Razan, correct. What about the other one, Razan? Yeah, correct. So others also, please calculate this, okay? Please calculate this. Now let's look at some other type of questions. But before that, let us also write a relationship between pKa and pKb of conjugate acid in this. Relation between pKa and pKb of conjugate acid base pair. Conjugate acid base pair. So in this case, we know that Ka into Kb is equal to 10 to the power minus 14. Hence, first of all, what I will do, I will put up log. So I will write log of Ka into Kb is equal to log of 10 to the power minus 14. Now, I will write log of Ka plus log of Kb, product rule, then minus 14 into log 10. This is what? This is the power rule. So log 10 it is equal to 1. So no need to consider that. Then I will multiply minus on both sides. I will get minus log of Ka plus minus log of Kb, which will be equal to minus into minus 14, which will be equal to 14. So minus log of Ka is nothing but pKa plus minus log of Kb is pKb. This is equal to 14. So this is the relationship between the pK and pKb of conjugate acid base pair. So that means if HF has some value, if HF has some pKa value, then the pKb for F negative, this will be equal to 14 minus the pKa of HF. Okay, 14 minus the pKa of HF. So this is the relationship between pKa and pKb. Is this clear, guys? Yes or no? Yes. Hello.
Yes, sir.
Clear now? Okay. Now let us write one question. Calculate the pH of calculate the pH of 1 into 10 to the power minus 8 molar HCl solution. And so this is a strong acid. So I hope all of you know how to calculate the pH, right? pH is equal to minus log of the concentration of H plus. So try to calculate the pH for this solution. है ना? Khalil, tell me, is this answer correct? Yes or no? What do you think, Khalil? Is this correct? Yes, Khalil, what happened? You tell me, is this correct? Yes or no?
Not sure.
Not sure. अरे ऐसे मतलब why are you not sure? ये क्या मतलब है not sure? The solution, what we have added in solution, tell me. What have we added? What did we add, Khalil? What was the chemical that we added?
HCl.
हाँ ये HCl ही है ऐसे कितना टाइम तो लग जाता है आप लोग HCl ही है. Now look at your pH. Then again look at what we have added. Then again look at the pH that you have answered. Then again, until and unless you get what is wrong, you keep looking at the chemical species that I have added and the pH that you have got. I think by 2-3 looks you will get what is the problem. Let me know if you understand what is the problem. Okay, what about others? किसी और को नहीं मिला? What happened? Razan, Mazia, Mehreen, Minashi. We have done these type of questions, na? You have given the concentration and you have calculated the pH. Look at your notebook and try to calculate the pH. And HCl is a strong acid. नहीं, आपने तो गलत निकाल दिया है. You have done some calculation mistake here. I think you ignored the minus log. You just took the log of H plus of the Rahman. Okay. Yes. Razan, can you turn the mic on?
Yes, sir.
How did you calculate? Can you explain?
So first,
अच्छा, by the
Then-
wait a second, एक second. खलील, आपको गलती समझ में आई? पहले ये बताइए आप, खलील. Khalil, did you get why is this wrong? Hello, Khalil.
Yes, sir.
You got it now? Why it is wrong?
Yes.
Okay, Abdurrahman, your answer is also wrong. You figure out why it is wrong. You look at the pH that you have answered and look at the species that we have added. Okay. और फिर pH आपने क्या बताया? Then you will understand why it is wrong. Okay. Harazan, you tell me. You first of all did what? Tell me.
so, HCl is equal to 1.0 into 10 raised to minus 8. So I took that and then I did it in the formula.
Okay. So you did that, na? Minus log of 10 to the power minus 8. यही बोल रही है ना आप? आपने ये क्या? हाँ? Yes, Razan?
No, sir.
हाँ.
Uh,
अच्छा, बोलिए.
minus log 1.05 into 10 raised to minus 7.
1.05 into 10 raised to minus 7.
Yes.
Why this?
These are a log of 7.
नहीं. Where did you get this number? So you tell me, how did you calculate the concentration of H plus? You're saying it is equal to 1.05 into 10 to the power minus 7. How?
For the concentration, I took the 1.0 into 10 raised to minus 8 for the concentration of H plus.
अरे आप कहना क्या चाहती हैं? Is this correct? Yes or no?
Yes, sir.
So this will be equal to minus log of, tell me, what did you take the concentration of H plus?
1.0 into 10 raised to minus 8.
1.0 into 10 raised to minus 8. ठीक है. After that?
Log of 7 is equal to the
Log of 7. एक second. अच्छा, so you calculated this. Yes, Razan? अच्छा, ये समझे हम.
Yes, sir.
ये तो आपने बहुत बड़ी गलती कर दी ना। देखिए ये क्या है, log A into B है ना, ये सर नो।
Yes, sir.
तो ये तो ऐसे होगा ना, माइनस log ऑफ 1, ये तो माइनस बाहर ही रख देते हैं इसको, माइनस log ऑफ 1 प्लस log ऑफ 10 to the power -8, ये तो ऐसे होगा।
Yes, sir.
फिर प्लस ये -8 बाहर आएगा, ऐसे होगा, सही है।
Yes, sir.
है ना, तो फिर तो आपने गलत किया ना जो भी किया है। ये सर नो रजान,
Yes, sir. I'll redo it.
वो आपने देखिए, आपने ना लाइक आपने गलत चीज अप्लाई कर दिया गलत जगह। वी हैव टू कैलकुलेट log ऑफ 10 to the power -8। जब हम लोग को 10 to the power -8 जब सिर्फ कैलकुलेट करना पड़ेगा, देन वी हैव टू जस्ट कैलकुलेट 10 to the power -8। देखिए इसको कैलकुलेट करने की जरूरत ही नहीं है, we never calculate this 10 to the power -8 ना, because we know what it is 1 upon, it is 0.000001। वो भी आपने गलत कर दिया, ठीक है। तो आप थोड़ा कंफ्यूज हो गए कि आपने ये कर दिया कि log ऑफ, आपने ये समझ लिया इसको, ऐसे कुछ किया होगा आपने, 10 to the power 8 is equal to 7, you did something like this ना, और -7
Yes,
कुछ तो
sir.
ऐसा कर, है ना। तो समझ में आ गया क्या गलती किया है आपने।
Yes, sir.
हाँ ठीक है, ओके फाइन। देखिए यहाँ पे दिक्कत क्या है, प्लीज लिसन हियर वेरी केयरफुली। Those who have got the answer, you must have taken the concentration of H plus. It is equal to the concentration of HCl because it is strong acid, and you must have done this. pH is equal to minus log of the concentration of H plus, concentration of H plus. So this will be equal to minus log of, this is equal to 10 to the power -8. So this will be equal to minus log of 10 to the power -8. So this -8 will come down. So it will be minus of -8 into log of 10. So we know that log of 10 is nothing, it is 1. So minus of -8, it will be equal to 8. Now, a simple answer would be like this, but we know that when we have added acid, our pH should not increase, it should be less than, it should be less than 7, right? The pH should be less than 7 when we have added acid. This is very important. Now we are getting more than 7, which is wrong. Now this is wrong. Obviously, it is wrong because when we add acid, the pH is not going to increase, it should decrease. So what is the problem? The problem is the concentration of H plus is so low. The concentration of H plus in neutral water, when we have in pure water, the concentration of H plus is how much? It is equal to 10 to the power -7. Now, when we are taking this 10 to the power -8, that means what? It means that we are adding very less amount of H plus, even lesser than whatever is present earlier. So when you are taking the concentration of just HCl and not considering this concentration, then it is going to be problematic. Now, when you have the concentration of HCl, that is acid added, and the H plus concentration, these are now comparable, then we have to consider both the concentration of H plus as well as the concentration of H plus from acid as well as water, as well as that of water. So here, when concentration of acid is either less than or equal to 10 to the power -6, then the concentration of H plus of water is also considered, because when we have neutral water, then also there is some H plus present. Water is also considered. H plus of water is also considered. Now, here we have two reactions. Number one reaction is H2O. It is giving me H plus ions plus OH negative ions. Now here we have the concentration of H plus as this is 10 to the power minus 7 molar. Second reaction is HCl. It is giving me H plus Cl negative, and here the concentration of H plus is 10 to the power minus 8 molar. 10 to the power minus 8 molar. So this is going to be our primary reaction, because here we have higher concentration of H plus, and this is the primary reaction, and in which we are going to add HCl. So when we have H2O and when we have added HCl, then I have increased the concentration of H plus ions. So when I have increased the concentration of product, so a human is adding H plus ions. So what is the human doing? Please tell me. What is the human doing? It is increasing the amount of product. Yes or no? When I'm adding HCl, I'm increasing the amount of H plus. Yes or no?
Yes, sir.
Okay. That means the reaction will go forward or backward?
Backward.
Backward. Very good. So what happens? We have this reaction, H2O, giving me some H plus, and it is also giving me OH negative. एक काम कीजिए आप लोग. First of all, write till here. These 3 points, right? Then we will understand more what is going to happen. Okay. So first of all, write till identification of primary reaction. And then raise your hand. Then we will understand more, because it is going to be lengthy, a bit lengthy. Okay. So since you have, I think you guys have written just 3 points, Anna. I think you guys have written, right? So here we have two reactions, HCl, the concentration from H2O, and also the concentration from HCl. Now, since we are adding very little of HCl, the reaction will go backward, but it will not be going very much backward. The extent of the reaction will not be very much high, because we are adding very less H plus ions. So the concentration of H plus essentially will be equal to the concentration of H plus from H2O plus the concentration of H plus from HCl. Concentration of H2O from concentration of H plus from H2O is 10 to the power minus 7 plus concentration of H plus from HCl is equal to how much? 10 to the power minus 8. Okay, 10 to the power minus 8. Now this will be equal to how much? This will be equal to how much, guys? We can write this as 10 to the power minus 7 plus 1 into 10 to the power we can write 0.1. 0.1 into 10 to the power minus 7. So I can take common 10 to the power minus 7. Common 10 to the power minus 10 to the power minus, this will be 1 plus 0.1, which will be equal to 1.1 into 10 to the power minus 7. Please tell me, is this clear till here? Yes or no?
Yes, sir.
Okay.
Yes, sir.
Now we have got the concentration of H plus as 1.1 into 10 to the power minus 7. We just need to calculate the pH. So the pH here, it will be equal to minus log of the concentration of H plus, which is equal to minus log of the concentration of 1.1. So minus log of 1.1 into 10 to the power minus 7, which I can write as minus log of. So how are we going to calculate this? Minus log of 1.1. So for 1.1, I will write minus log of 11 into 10 to the power minus 8. So this will be equal to minus log of 11 plus log of how much? Plus log of 10 to the power minus 8. This will be equal to minus of log of 11 plus minus of 8. So we can write this as 8 into minus log 11, and this will be 8. So 8 minus log 11. 8 into 8 minus log 11. Now, so for log 11, what I will do, I will approximate it to log 12 because one number higher. Hai na? I hope you guys remember one number higher. So 8 minus log of 12. So 12 will be 4 into 3. 4 into 3, 12. Hai na? So log of 3 is how much? 0.48 minus log of 4. Log of 4 is how much? 0.6. So just tell me how much is this? 8 minus 0.48 minus 0.6. This will be approximately 6.92. This is the piece that you will get. If you want the exact value of log 11, so you can write log 11 as log 10 plus log 12 by 2. This will get you a bit more near. Write this down. Raise your hand if you're done. Okay, so let us just write a small topic. Then again, we will meet after 1 hour. Okay, then again, we will meet after 1 hour. So, or else what we can do? Okay, we can write a relationship of polyprotic acids. Small topic. Polyprotic acids. Polyprotic acids means the acid which has more than one ionizable hydrogen. Acids that have more than 1 ionizable hydrogen. Okay, so let us say HF. So HF is going to give me only how many hydrogens? Only one hydrogen, yes or no? Only one ionizable hydrogen is there, right?
Yes, sir.
But if I have H2SO4, then it has how many ionizable hydrogen? 2 ionizable hydrogen, right?
Yes, sir.
Now, so these are known as, whether you can call it diprotic, or we can also call this dibasic. That means it can handle 2 bases. It can handle 2 bases. So if I have one ionizable hydrogen, then it is known as monobasic. It can handle 1 mole of base, that is 1 mole of OH negative. If I have 2 ionizable hydrogen, then it is known as dibasic. Then we have 3 ionizable hydrogen, then it is known as tribasic. Okay, so these 2 and 3 ionizable hydrogens and 4 ionizable hydrogens, these are what? These are polyprotic acid. These are polyprotic acid. Okay. So when we have to look at these polyprotic acids, for example, let us talk about H2CO3. Let's talk about H2CO3. H2CO3. Now, it will first of all give me H plus ion plus HCO3 negative. So let us tell that this is the Ka1. This is the Ka1. Now HCO3 negative, it can also dissociate and give me HCO3 negative can dissociate and it can give me CO3 2 negative, and let us call this Ka2. That is the second dissociation constant. Now, what will be the Ka1? The Ka1 will be equal to the concentration of H plus into the concentration of HCO3 negative divided by the concentration of H2CO3. Ka2, it will be the concentration of H plus into the concentration of CO3 2 negative divided by the concentration of HCO3 negative. Concentration of HCO3 negative. Now, when I look at the total, the overall equation of this acid H2CO3, then I can add both of these and I can say that I can cancel this, right? I can cancel these 2 things and I will be getting H2CO3 is in equilibrium with 2H plus CO3 2 negative. And this will be the overall Ka. Overall Ka of the acid, which will be equal to the concentration of H plus ions squared into CO3 2 negative divided by the concentration of H2CO3. So when I look at the overall Ka and the Ka1, the first dissociation constant and the second dissociation constant, Ka1 and Ka2, then I can see the relationship that Ka, it is equal to Ka1 into Ka2. Can you see this? Yes or no? Let me write it and show you guys. Ka1 and Ka2. First of all, let me write Ka1. Ka1 is the concentration of H plus into the concentration of HCO3 negative divided by the concentration of H2CO3 into the Ka2 is H plus into CO3 2 negative divided by HCO3. HCO3 negative. So here also we can cancel HCO3 negative, HCO3 negative. And what is remaining, guys? The remaining we have is H plus into H plus square into CO3 2 negative divided by H2CO3. Therefore, we can say in general In general, what do we have? Ka1, you can write that Ka is equal to, of any acid, it will be equal to Ka1 into Ka2 into Ka3 and so on. To get the Ka, the relationship we are finding. You got it, Abdurrahman?
Sir, to find the relationship.
To find the relationship. When you see this, you can understand that the relationship is what? Between Ka1, between the first and second dissociation constant and the overall dissociation constant. When you look at these, expressions, then only you can see that it is Ka1 into Ka2 is equal to Ka. Yes or no?
Yes, sir.
So just by looking at we have got this expression, and then we have to, from these expression, look at a pattern, then generate a relationship. It is purely numeric, okay? It is purely numeric relationship, nothing else. So in general, we have Ka is equal to Ka1 into Ka2 into Ka3. Okay. Now you guys have to tell me, this is the first dissociation. This is the second dissociation. Which will be easier, first or second? Which will be easier, first or second? What do you think, guys? Taking out a positive thing from neutral will be easier, or taking out a positive thing from negatively charged will be easier? What do you think? Where there will be more force of attraction between the positive charge? Positive and neutral will have more force of attraction between them, or positive and negative will have more force of attraction between them? Think and tell me.
Positive and negative.
Positive and negative will have more force of attraction between them, yes or no?
Yes, sir.
So it will be very difficult to remove proton from negatively charged HCO3 negative. Got it? Yes or no? Our HCO3 negative, that is the second dissociation that we are writing, the second dissociation in which we are taking the H plus ion proton from HCO3 negative, which is negatively charged. So it will be not giving H plus so easily. It will not be giving H plus so easily. Is this understood? Yes or no, guys? Please tell me. Is this understood? Yes or no?
Yes.
So K, now when we have the first dissociation easy, we will get more H plus from the first dissociation. That means we'll have the Ka1 higher than Ka2 and then Ka3. So Ka1 is highest, followed by Ka2, followed by Ka3 and so on. Now, but we know that the relationship between Ka and pKa is what? Inverse. So pKa will be, pKa1 will be smallest, followed by pKa2, followed by pKa3 and so on. Okay. So this is it for now. We'll have 1 hour break. You will have 1 hour break, not me. And then we will meet after 1 hour. Okay, guys. Then I will share the PDF with you guys. Chalo. Thank you very much. Bye bye. Take care. We will start a new topic.